Motion in a straight line. Speed can be defined as distance traveled in unit time. Formula for average speed is total distance over total time. Velocity is speed plus direction, or you can define it as a rate of change of displacement. Displacement is distance traveled in a specific direction, or in other words, if you specify direction along with distance, then that will be displacement. There is a formula for average velocity, u plus v over 2. U stands for initial velocity, v for final velocity divided by 2. Displacement is distance traveled in a specific direction, or you can say it is the shortest distance. Acceleration is a rate of change of velocity. When an object is speeding up, means gaining speed, then we can say the object is accelerating. Deceleration is again a rate at which velocity is decreasing. In deceleration, object is losing speed, slowing down, and it's the same thing as acceleration, but in this case the object is slowing down. You can call it as negative acceleration. There is a formula for acceleration which work both in case of acceleration as well as in deceleration. A equals to v minus u over t. U stands for initial velocity, v for final velocity, and t is equals to time taken. Displacement or distance time graph. In this graph, distance or displacement is on y-axis and time is on x-axis. If you have a straight line like this purple line, then this shows constant velocity. And if you find the gradient of this line, you will get the velocity of the object. A horizontal line is rest, like time is passing on, but no distance is traveled. So the object is at rest. A velocity time graph. In this case, velocity or speed is on y-axis, time is on x-axis, and a straight line like this purple line represent constant acceleration. A horizontal line represent constant or constant velocity or speed. Line with decreasing gradient represent constant deceleration. So this is deceleration. So it's a straight line, so it is constant deceleration. You can find out distance using velocity time graph, and that will be area under the graph. Acceleration is gradient, or you can use the formula if you want. U is initial velocity, v is final velocity, t is time interval. You can take speed. If instead of velocity, speed is given, you can take speed in place of velocity, or you can take velocity in place of speed if required. Free fall. When an object is falling under the action of gravity or gravitational pull of the earth in such a way that air resistance is negligible, then the acceleration is 9.8 meter per second square, and this value is fixed. A car driver applies the brakes to bring a car to rest with constant deceleration of 4 meter per second square in a time 8 seconds. What is the average speed of the car during this time? So deceleration is also acceleration, but it's negative acceleration. So formula is the same, v minus u over t. V is final, u is initial, t is time. Acceleration is given to you as 4 meter per second square. Since it is deceleration, so you can put this negative sign on your own. Time is also given to you, 8 seconds. 8 seconds. And since brakes are applied and the car is coming to rest afterwards, so the final velocity is 0. And what is the average speed of the car? Average speed is actually u plus v over 2. So you need initial velocity, initial speed in this case. Then you can find average speed. So using this formula, I'm finding the initial speed. Use the initial speed, plug all the values. Simplify, you get u equals to 32. Then you come to the formula for average speed, u plus v over 2, plug all the values. You will get 16, which is option C. The speed time graph for a racing car is divided into 4 sections P, Q, R, and S. The car starts the race but soon crashes into the wall of tires. Which section of the graph show that there is an acceleration that is changing? So acceleration that is changing means acceleration is not constant, it's changing. So instead of a straight line, you have a curve. So it's better to see where you have a curve. You have a curve over here, and you have a curve over here. So at these two positions, Q and R, you have a curve. So the option is C. Okay, a steel ball is dropped from the top floor of a building. Air resistance can be ignored. So which statement describes the motion of the ball? We know when air resistance is ignored, then the object falling under gravitational pull of the earth move with constant acceleration, which is 9.8 meter per second square. So the correct option is A, the ball fall with constant acceleration. Uh, Question number 3. The diagram shows a velocity time graph for an object which is accelerating. You can see it's a straight line. And a straight line in case of speed time graph represent constant acceleration. What is the value of this acceleration? You can use the formula again, v minus u. V is final velocity, which is 120, and initially the beginning of time it is 20, u is 20, and time interval is 40. So plug all the values, you will get 2.5, which is option B. A skydiver jumps out of a hot air balloon which is 4,000 meter above the ground. At time equals to 30 seconds, she opened her parachute. Figure 1.1 is the speed time graph of her fall. Label with letter X the point on the graph where the skydiver opened her parachute. So when she opened her parachute, there is a sudden decrease in speed. So you have to follow where is the sudden decrease in speed. Here you will see that there is a sudden decrease in speed. So you have to label it with X, so X is over here. Label with letters Y and Z the two parts of the graph where the skydiver falls at terminal speed. Terminal velocity or terminal speed is actually a constant speed, and it is a point or it is the point at which the resultant force is zero. All forces are cancelling the effect of each other. That is why the object is falling with constant speed. Or if you consider the forces, if an object is falling, then weight is the force which acts downward, and air resistance is the force which act upward. Weight is always constant while air resistance increases with speed. So when object is falling, a stage or point will come where air resistance get equal to the weight. The two forces cancel each other and the object fall with terminal speed, constant speed. So you have to label where is the speed is terminal, it's constant. So these are the 2 points Y and Z where the speed is constant. So as you can see a horizontal line, there is no increase or decrease in the speed. Describe in terms of forces acting on the skydiver a motion between leaving the balloon and opening her parachute. As I pointed out here, that the two forces are weight and air resistance on the parachute. So weight is acting downward and air resistance will act in opposite direction, acting upward. So in the graph you can see till 10 seconds uh, uh, weight is greater than air resistance because the parachute is accelerating, which means there is some resultant force, and that resultant force is weight minus air resistance. And after 10 seconds, the two forces get equal. And when air resistance and weight get equal, and the object move with constant speed because there is no resultant force causing acceleration. So after opening parachute, over here you can see this sudden decrease in speed because air resistance increases and become equals to the weight, greater than the weight. So there is a sudden decrease in speed. Same thing is written here. Now in C part it says calculate the average speed of the skydiver in the first 4 seconds. First 4 seconds. You can remember the formula. Average speed is u plus v over 2. U is initial. This is in the beginning of time is u 0, and this is 40, which is the final speed. We are only interested in first 4 seconds. So u plus v over 2 is the formula. Plug the values, you will get 20 meter per second. Question number one. A bus is traveling between points A and D. There are four bus stops A, B, C, and D, but the bus does not stop at B, as shown in figure 1.1, and the speed time graph is given to you. Part A. Describe the motion of the bus between each of the bus stops. Select the appropriate description from the list below. So there is a list over here. You have to choose from here and answer 1, 2, and 3. In 1, they're saying what is happening between A and B. A and B, you are seeing that it's a curve, not a straight line. Curve is representing uh, changing acceleration. If it is a straight line, you can say acceleration is constant, but since it's a curve, it's a changing acceleration. Then you have to follow the gradient of the line. Like if this is the curve, then you have to imagine a tangent touching outer boundary of the curve. And if gradient of the tangent is decreasing, this means that in this context, acceleration is decreasing. So the option is decreasing acceleration for A part. Between B and C, you can see it's a horizontal line, speed is constant. So the correct option is moving forward at constant. Sorry, it's not moving backward, nowhere, not possible. Moving forward at constant speed. Then in the third part between C and D, this is a straight line and with negative gradient. The downhill line is has negative gradient, and negative gradient is deceleration, but there is no choice like deceleration over here. So the correct option is constant acceleration. Constant acceleration because it's a straight line. Deceleration is also acceleration. Now find in B part, the average speed of the bus between A and D is 23. And you have to find the distance between A and D. Since average speed is given to you, so you better focus on average speed. Average speed is total distance over total time. And mind that this thing is in kilometer per hour, while the time is in minute. So there is a trick over here. You have to convert minute into hour. So you're looking for total distance. Your average speed is 23. Time interval between A and D is 2 minutes. So if you divide 2 by 60, you get R. And if you write this R over here in place of time and cross multiply, the total distance is 0.77 kilometer. The bus stops at D for 1 minute and then travel at a constant acceleration for 30 seconds. Sketch a possible graph for this additional motion. So what is happening? The bus stop at D for 1 minute. So you will show this horizontal line for 1 minute. This means no motion, speed is 0. And then it accelerates for 30 seconds, which is half a minute. And this is half of a minute. So you can see a horizontal line representing constant acceleration. This you have to draw.